welcome to All Solution Physics. Today we want to attempt this question on vector that says an aircraft attempts to fly due north at 100 kilometers per hour. If the wind blows against it from east to west at 60 kilometers per hour, its resultant vector is. So now let's look at how we can find resultant vector in this question. But before then, we have to represent this in a diagram. So here I have my solution. Okay, to do this question, first of all, I must represent the cardinal point. Here is the cardinal point. The north, south, east, and west. Okay, let's follow the question one after the other. It said an aircraft attempt to fly due north at 100 kilometers. So this is northward direction. That means it moved due north at 100 kilometers per hour. And then from east to west, the wind blows from east. This is east. So this is the starting point to west. So we have this here. And is 60 kilometers per hour. And the question said find the resultant vector. So we know what we need to do is that we complete it to become a square. We should have this. You have this. Now the resultant vector would be from their point of intersection, which is this. This becomes their resultant vector R. So now you know vector has both magnitude and direction. So to find the magnitude of this resultant vector, we use Pythagoras theorem. So using Pythagoras theorem, which says that R square equals to A square plus B square. This is not the original law. The original law says that the square root of the hypotenuse equals to the square root of the opposite plus the square root of the adjacent. So now we interpret it based on the question we have here. So that means the resultant vector equals to the square root of A plus the square root of B squared. Now we substitute into this formula. Then let 60 be A. We'll have this to be 60 squared plus 100 squared. Then we have 60 squared is 3,600 plus 100 squared is 10,000. So if we add them together, we have it to be 13,600. So we find the square root of this, and we have it to be the square root of 13,600 would give us 116.619. Then if we approximate it, we have it to be 116.62 kilometers per hour would be the resultant vector. This is the magnitude of the resultant vector. Now let's look at the direction. To find the direction of this same vector, we use Pythagoras. To find the direction of this same vector, we use trigonometry ratio, in particular tan theta, where theta is the angle, tan theta always equals to y over x. That is opposite over the adjacent. Here it's our opposite, you know, the angle inclined to the horizontal. So if we substitute here, since our opposite is 100 over our adjacent is 60, then we have here to be tan theta equals to, if you divide 100 by 60, what you're going to have would be 1.667. Then remember, what we are solving for is theta, not tan theta, so we'll make theta the subject formula. So tan would cross to this side and we have tan inverse of 1.667. So if we find a tan inverse of 1.667, we are going to have 59.08 degrees. Approximately would give you 59 degrees. So this is the angle of the resultant vector inclined to the horizontal, which means that the vector is moving in the direction of west, 59 degrees of north. That is the direction of the vector quantity. Thank you. In our next class, we'll also talk about some other questions and also bring more examples to solve. And I'll give you the clue about vector quantity. Stay tuned.